Are you ready for mixture problems? In this section, we're going to solve mixture problems. What's going to be really helpful for us is a chart. And all of your charts are going to have this similar setup. Across the columns, you're going to have amount of the materials that you have. The middle column is usually going to be price or percent of what you have of that material. And the last column is going to be total. Your rows are going to turn out to be two different items, for example, water and antifreeze, or cashews and peanuts, two different things, and then the mixture of the two together. So every single problem I would try to create this chart with. The owner of a fancy food shop wants to mix cashews selling at $8 per kilogram and pecans selling at $7 per kilogram. How many kilograms of each kind of nut should be mixed in order to get 8 kilograms worth $7.25? This is number 1 on page 322. In these first few problems, they give you the chart to fill in. So let's try to do that now. If X is the number of cashews we have, and we want to create a mixture that's 8 kilograms total, that means 8 kilograms is the amount of the mixture. But how many pecans does that leave us? Well, if X is the number of cashews, then 8 minus X, the total amount minus how many cashews there are, will be the amount of pecans there are. The price per kilogram is pretty easy to fill in. The cashews are 8, the pecans are 7, and the new mixture is $7.25. Total we will find by multiplying across. 8x, 56 minus 7x, and 8 times 7.25 is 58. From the chart, we can now set up an equation to solve this. If I know that this is the amount of cashews and this is the amount of pecans, this must be the total added together. So I'm going to say that 8x plus 56 minus 7x equals 58. Combine like terms, I'm going to be left with 1x plus 56 on this side equals 58. Subtract 56 and x is 2. That means that we'll have 2 kilograms of cashews and 6 kilograms of pecans. The question is asking for how many kilograms of each, so we just figured that out. 2 kilograms of cashews, 6 kilograms of pecans. This is number 2 on page 323. A chemist has 40 milliliters of a solution that is 50% acid. How much water should he add to make a solution that is 10% acid? Let's fill in the table. The original amount of acid or solution that he has is 40 milliliters. He's going to add water to it to create a new solution. That means the new solution will have 40 from the original plus how much we add of the water. The percentage of each of these is relatively easy to find. The original, it's given to us, has 50%. If we're adding pure water to a solution, pure water has no acid in it, so 0%. And the new solution we want to have 10% of acid. Now we multiply across. 40 times 50% is the same as 40 times the decimal, 0.5. If you're ever having issues multiplying with these percents, make them into decimals first. That means we have 20 is the total amount of acid from the original solution. 0, because x times 0 is 0, means that we're getting no acid from the water. The new solution will have 10% of this being acid. So again, 10% I'm going to multiply by 0.1. 40 times 0.1 is 4. 0.1 times x is 0.1x. Now I can set up my equation saying that the amount of acid from the original plus the amount of acid from water equals the amount of acid that should be Let's now finish the problem by solving. 20 plus 0 is just 20, plus 4 plus 0.1x. Subtract 4 from both sides. And now divide by 0.1. 16 divided by 0.1 is 160. That means there's 160 milliliters of water that must be added to create the new solution.